and impulse signal. These are all the notations. Okay, and again this is the notation in the discrete domain. Then how to generate the signal? Okay, this is the common formula, and again you can take the same formula in the discrete domain. Okay, and by putting the value for k, if k is equal to 0, then it is giving you the step signal. K is equal to 1, ramp. K is equal to 2, parabolic signal. Similarly, in the discrete domain also, it's giving you the signal. And finally, how to generate the impulse signal? Impulse signal is generated from the rectangular pulse that we will see separately. Okay, how to generate the impulse signal from the rectangular pulse. Okay, then we'll go in detail about the individual signals. Unit step signal. Okay, for unit step signal, u of t is equal to 1 when t is greater than or equal to 0, and it is 0 when t is less than 0. So when t is in between 0 to infinite, then you are having value 1. In all other cases, the value is 0. And again, mathematically, sometimes they may not give you the equality sign, because in the continuous domain there is no meaning for equality sign. Okay, so it may be t greater than 0 also. And in a discrete domain, when u of n is equal to 1, when n is greater than or equal to 0, here that equality sign is very, very important. Okay, when n is greater than or equal to 0 means at 0 you are having sample value of 1. Okay, sample value of 1. And similarly, you are having samples at 1, at n is equal to 2, 3, 4, 5, like that, and it goes up to infinite. It goes up to infinite. But when n is less than 0, that means when n is negative, then your value is 0. Your value is 0. And then similarly, what is the ramp signal? Okay, ramp signal, unit ramp signal. The another name for ramp signal is called linear signal. Another name for ramp signal is called linear signal. You know from the mathematics, if some signal goes through origin, that then that can be classified as a linear signal. Okay, linear equation. Okay, so the ramp signal r of t is equal to t when t is greater than or equal to 0, or 0 when t is less than 0. So once we plot here, and you know whenever you are having only one variable t, and you know the slope here the slope is 1. So this is your time axis, 0, 1, 2, like that, and similarly here also 1, 2, 3. Then it goes like this. Okay, that means what? When at time t is equal to 1, you are having value 1. When t is equal to 2, you are having value 2. When t is equal to 3, you are having value 3. Okay, so this is the notation for ramp signal. This is the notation for ramp signal. And what is the slope? What is the slope here is 1. Okay, slope here is 1. When slope is high, it goes in this direction. If slope is greater than 1, it goes in this direction. If slope is less than 1, it goes in this direction. But that is in mathematics. But here it is always 1. Here slope is always 1. Okay. So similarly, and again this equation is called a linear equation, because you can write the mathematical equation that will be linear. Okay. So and again, in a discrete domain, r of n is equal to n when n is greater than or equal to 0, or 0 when n is less than 0. Okay, then how to denote this? Say this is n. So now 0, 1, 2, 3. This is 1, 2, 3, like that. So exactly at 0. Okay, exactly at 0, the value is 0. When n is 1, the value is 1. When n is 2, the value is 2. When n is 3, the value is 3. Like this you have to denote. Okay, so this is r of n. Okay, this is in the discrete domain. The next one is parabolic signal. Okay, so the parabolic signal. Okay, in the parabolic signal, what is the equation? P of t is equal to t square divided by 2. And when t is greater than or equal to 0, 0 when t is less than 0. You know this equation, t square always represents the parabolic nature, and you are having some extra constant. So like this it goes. Okay, so again this is t, this is p of t, this is p of t. Similarly for p of n, this is n square by 2, where n is greater than or equal to 0, 0 when n is less than 0. And here also you can put like this, but this is the actual value. Okay, This is the actual value. So in between you are not having any value. Okay, that's the idea. So this is n and this is p of n. Okay, 0, 1, 2, 3, like that it goes. Then next one is unit impulse. Okay, unit impulse. Unit impulse signal. That notation is like this, del t. Unit impulse signal notation is like del t. Then what is the meaning of this one? When del t value is equal to 1 at t is equal to 0, and then 0 if t is other than 0. That means what? Exactly at t is equal to 0 you are getting some value. If t is not equal to 0, it may be positive or negative, then you are getting 0. So how to denote this? This is the axis, so exactly you are having only one impulse, that value is 1. This is at 0, then your axis goes like this, like -1, -2. And only one signal you are having, only one impulse. That means suddenly it comes and it disappears. Okay, see, nothing is there, suddenly something comes, then disappears. Okay, so that is the example for impulse. Say for example, when you are using kickstart for the bike, suddenly you are creating the impulse. Okay, see, you are not doing anything, you are not giving any force to that kickstart. That suddenly when you want to start the bike, you are giving the some kick. Okay, then after that you are leaving that. Okay, after that you are leaving that. That's example for unit impulse. And even in modern days you are using electric switch. What you are doing, so when you want to start the bike, you are pressing the switch and suddenly immediately you are releasing the switch. Okay, immediately you are releasing the switch. In the olden days you might have observed, whenever you are using the kickstart of the bike, that will disturb the phone signal for a moment, because when you use the kickstart, it will create the impulse. Okay, that impulse consists of many frequencies that I will discuss later. Okay, among that, the frequency that you are operating in your mobile phone, that will disturb. Okay, because that will create all frequencies. Okay, among one frequency you will be using for your mobile phone, so that your mobile phone will be disturbed for a few seconds. Okay, then later it disappears. Okay, that's the example for unit impulse. Example for unit impulse. And one more confusion here comes. In general, in some book they might have mentioned del t is equal to infinite when t is equal to 0, and then 0 when t not equal to 0. Then doubt arises. Something what at t is equal to 0, the amplitude goes to infinite. Okay, then in later classes I will explain how to derive the unit impulse from the rectangular pulse, then how it goes to infinite. Okay, when they are saying simply like an impulse function, okay, they will not mention like unit impulse. If they mention like impulse function, then this may go up to infinite. Then t value is, it goes like this. Okay, and then whatever may be the function, let it be unit impulse or impulse. Okay, in general this formula is always true. Okay, whenever impulse is coming to our mind, minus infinity to plus infinity, del t is equal to 1 always. Please, very important formula. Okay, integral minus infinity to plus infinity, del t is equal to 1. In later classes I will prove this, how this is equal to 1. At this point you just remember this formula. Okay, and the next one is again in the discrete domain. In the discrete domain, del n is equal to 1. Del n is equal to 1 for n is equal to 0, and 0 when n not equal to 0. And then and again here summation n minus infinity to plus infinity, del n is equal to 1. Okay, so here it goes like this, del n, okay, again 0, 1, 2, minus 1, minus 2, like this. Okay, so again this del n is called the impulse function, and then sometimes this del t is called, instead of impulse, sometimes this is called as direct delta function. Okay, so then next one is other signals, other basic signal, elementary signals. Say for example, if you are having real exponential signal, real exponential. Okay, because exponential signal can be imaginary also, because you might have heard e power j theta like that. So but here we are discussing about real exponential. So if it is x of t, for x of t, some constant into c power at, some constant into c power at, and now I am assuming my a value is greater than 0. That means what? A is positive. That means what? A is positive. And again, my time can be positive or negative. Say for example, if I am taking time axis like this, my time can be positive or negative. When my time is negative, say if it is minus infinite, I will get 0. When my t is equal to 0, e power 0 is 1, then you will get c here. Okay, when my t increases and then this increases, this value increases. So what I can do, I can denote like this. Okay. This is the exponentially rising function, but this is true only when a is equal to greater than 0. A is equal to greater than 0. Similarly, the same function I can analyze for a less than 0. That means what? A value is negative. A value is negative. Now, what happens? Already a is negative. If your time is negative, negative and negative is positive, e power positive. That means if you are at infinite, then e for infinite is infinite. Then the diagram goes like this. Okay, and again this is the c. Okay, so this is exponentially increasing, this is exponentially decreasing. Okay, so and then whether either it is increasing or decreasing, that is decided by the a value, that is decided by the a value. And then same thing you can mention in discrete domain also. In discrete domain, x of n is equal to c a power c e power a n. Okay, if a is greater than 0, then your diagram goes like this. Exponentially it increases. Okay, this is n, this is x of n. Similarly, if a is less than 0, and then your diagram decreases like this. Okay, so this is in discrete domain. Then next we will see the cosine signal. Okay, cos signal. Okay, so cosine signal. Okay, so mathematically this is written as x of t is equal to cos omega t. In general, this is written as cos omega t plus theta, but for the moment you forget about theta. Okay, only omega t is there. Okay, so what happens? How you are drawing this one? See, when omega t is there, what is actually happening? This omega t can be 0 degree because omega is constant, t is variable. When you are increasing t with omega t, this angle is getting increased. Please always in future, if omega t comes, please imagine as a angle. Imagine as a angle because omega is frequency, t means time, both will give you the angle. Okay, so then what happens? After some time, 10 degree will come, then 45 degree will come, then it keeps on increasing because your time is going in the forward direction. So that is in the increasing direction, in a positive direction. Then your angle is going like this, 90 degree, 180 degree, and then 360 degree. It goes as a cycle. Then how to denote this? Say when t is equal to 0, cos 0 is 1. Okay, cos 0 is 1. So my diagram will be something, it will start here. Okay, then it goes like this. Okay, this is the function of cos omega t. Function of cos omega t. Now, the problem is, suppose if somebody gives cos omega t, okay, plus theta, and the theta could be anything. It may be positive or negative. Already phase is provided by time. Apart from that, you are adding some constant phase. Okay, so theta could be anything. Say for example, if theta is 45 degree, what will happen? If theta is minus 45 degree, what will happen? In reality, theta can be anything. Then how your diagram will look? Say if this is 0 reference axis, this is time, this is x of t, then where exactly my diagram will start, either it will start here or here, because one thing is clear, when t is 0, this is not cos 0 because theta is there, cos 45 degree. So what is the idea? When t is equal to 0, what is the idea? What I am getting? Cos 45 degree. Okay, then after some point of time, my omega t will give you some value, say angle. Say suppose if it is giving you 45 degree at some time, then your cos goes to from 45 to 90 degree. Then where exactly my diagram will start? Okay, so either it will start here or here. Okay, yes, anybody? What will happen? What is cos 90 degree? Now the doubt arises. Definitely it is starting at cos 45 degree. Cos 45 degree means it can be here or here. Okay, because cos 45 degree is 1 by root 2. Here also it can start, here also it can start, but it has to start here because after cos 45 degree you are getting cos 90 degree, but cos 90 degree value is 0. Here only you are getting 0. That means my diagram is going to start here. So I will draw the diagram like this. Okay, so now my diagram is going like this. Okay, that means if you see that diagram is already there, now you have shifted your axis like this. You can imagine like this, or otherwise you have moved your waveform towards left side, or if you keep the waveform stationary, you move this central axis towards right side. That's the idea. Okay, so this is the cos omega t plus 45 degree. I can also take cos omega t minus 45 degree. Okay, if x of t is equal to cos omega t minus 45 degree, then how will be the diagram? That means it will be shifted in the opposite way. So it goes like this. It will be shifted in the opposite way, no problem. Okay, now this is the, and again this is t, and this is x of t. Okay, then you take some different value for omega t, then you verify whether this is correct or not. You verify whether this diagram is correct or not, or you take some help of computer simulation. Then you put different angle here, positive theta, negative theta, whatever, because theta can be anything, not necessarily to be 45. It can be anything that may be positive or negative. Then verify your answers. Okay. Then next one is sine signal. Sine signal. Sine signal, say x of t is equal to sine omega t plus theta, sine omega t plus theta. For a moment I assume that theta is equal to 0. If theta is 0, then my diagram goes like this. My diagram goes like this. Okay, this is x of t and this is t. And the next one is rectangular signal. Next one is rectangular signal. Is everything is clear, audible? Somebody please respond.
Yes, sir.
Okay, thank you. Next one is rectangular signal. It goes like this. Say, this is my time axis, amplitude axis. If I take the diagram like this, say it starts at minus t, end at plus t, this is a, then this signal is denoted as x of t is equal to a rectangular. T means independent time variable because x-axis is time variable. This a is amplitude, a whatever available there. Here in the denominator, I have to put the pulse width. Okay, what is the total pulse width? This is t and again this is t. What is the total pulse width? 2t. I have to put the pulse width. Or sometime in the question in the exam, they used to give like this also, minus t by 2 and then plus t by 2. This is a. Then how I have to denote? This is x of t, a rectangular, small t divided by t only, because t by 2 plus t by 2 is t only. So this is the idea. Okay, so next we will see the signum function. Signum signal. It is something similar to step functions, but the step value is 1 for positive t, but the step value is negative for negative t. Okay, so this is minus 1, this is plus 1, okay, this is 0 axis, t, this is called as Sgn of t. What is the meaning? See, the Sgn of t means this is giving you plus 1 when t is greater than 0, minus 1 when t is less than 0, minus 1 when t is less than 0. The same you can denote in discrete also. Okay, so if you put the pulse train like this, then this is denoting signum function in discrete domain. So Sgn of n plus 1 for n greater than 0, minus 1 when n is less than 0. You have to be very careful here. They are not using n is equal to 0 here. N is equal to 0, they are not utilizing. Okay, so this idea. The next one is triangular function. Okay, next one is triangular function. Say this is minus t by 2, this is plus t by 2, amplitude is a, and x of t. And also you should know what is the slope of this line. Slope of this line, the slope of this line is positive, slope of this line is negative. Okay, it's very simple. When you see it from the left side, if something is going up, the slope is positive. If it is going down, that slope is negative. It is immaterial where the line is falling. It may be on first quadrant or second or third or fourth. Don't worry about that. You see just whether either it is going up or going down. If it goes up, slope is positive. If it goes down, slope is negative. And you know what is the slope value? Change in y divided by change in x is called as slope. Change in y divided by change in x is called as slope. So how can I write the function x of t here is equal to a triangular small t divided by pulse width. What is the pulse width here? Just a t. Now somebody tell me what is the slope here? The slope here is change in y is a. What is change in x? Say that is t by 2. Now I know this is positive slope, so don't worry about other things. So the slope is 2a divided by t. Here slope is change in y is a, change in x is t by 2. But I know the slope is negative, so the slope here is minus 2a by t, 2a divided by t. Okay, so that's idea to find out the slope. We have to find out the slope. And again, there are other method also. Other method in mathematics, you know, once if you know these 2 points, you can write the equation for the 2 point. Then your equation will be in the format y is equal to mx plus c. Then you can find out what is m. Then also it will give you this value only. Okay, try to find out that. Okay, see, take the point values. This is minus t by 2 comma 0. What is this? Minus t by 2 comma 0, and here 0 comma a. Then you form the equation. Okay, you know how to form the equation once if you have 2 point. Then from that equation you try to observe what is m, whether both are same or not. Okay, then the next one is complex exponential signal. Complex exponential signal. Okay, so it is denoted as x of t is equal to e power j omega naught t. And again, complex in the sense, even you can take it in some other format also. Like this also you can take, no problem. Because we are not telling imaginary, it's like a complex. So you can take alpha j omega naught t also. Then how can you write e power alpha plus e power, so e power alpha into e power j omega naught t. Okay, e power j omega naught t. Now, dealing with this function is okay because it is purely real. Then how to deal about this function e power j omega naught t? Now I am worried about this one. So e power j omega naught t. Suppose this I am assuming as some amplitude a. Okay, e power alpha is some value. Okay, so and again you can take t also here, no problem. Okay, alpha t, that I can write it as a of t function of t, no problem. See, if you are thinking like this, okay, then also it's okay, alpha t. Then my a is not simple a, it's function of t, a of t e power j omega naught t. Now, how can I expand this function? This is a of t, e power j omega naught t can be written as cos omega naught t plus j a of t sin omega naught t. Okay, like this you can expand, because once if you have a complex function that can be written in terms of cos theta and sin theta. And again, even sometime instead of this omega naught t, sometime they used to give omega t plus pi. Say, for example, sometime the function could be like this, e power j omega t, okay, e power j omega t plus pi. Then again, it's very simple. You can write like this, okay, cos omega t plus pi, okay, then plus j sin omega t plus pi. Okay, so whenever you have both cos and sine, okay, in order to differentiate this, we are using j. Okay, please imagine what is the need of complex number. Okay, the need of complex number is if something is going in this direction, the other variable is going in this direction. To denote that only we are using mostly complex numbers. Say what is the meaning? If cos is going in this direction, then sine is going in this direction. Always there is some 90-degree phase offset is there. To denote that only we are using plus j. To denote that only we are using plus j here. Okay, then what is the relationship between all the signals? Okay, so relation between u of t, r of t and p of t. What is the relationship between the basic signals? And also I think del of t also should come. Something they missed, I think del of t, yes, and also with the del of t. Now, for example, what is the signals you are having? See, very basic signal is impulse. You are having impulse and you are having step. Okay, you are having ramp. You are having parabola. Then what is the relationship among all these signals? Say impulse means del t and this is u of t, this is r of t, this is p of t. Okay, once if you see very carefully, say ramp value is t, simply t, then this value is t square by 2. Okay, then don't worry about that positive side because always all the signals is working on the positive side. Okay, t is greater than 0. When this is t, if you integrate this, you are getting this one. If you integrate this, you are getting this one. Then if you differentiate this, differentiation of t with respect to t is 1. Then that means what? Once if you integrate this, you are getting ramp. And similarly, once if you do the differentiation of constant is 0, but this is not the real constant. This is like suddenly increasing and then becomes constant. Okay, it is suddenly increasing, then becoming constant. If it is really constant always, constant means it is constant for all time, but this is not a true constant. It is constant only for positive time period because it suddenly increases. Okay, previously it was 0. Then to denote that only we are using del t. We cannot put 0 because it is not a real constant like this. See, okay, so it is suddenly increasing. That's why to denote that value where it has increased, exactly at what point it has increased, to denote that only we are using impulse. Then finally, once if you have impulse, if you do the integration, you will get 1. If you do the integration of this one, you will get t, and again integration means t square by 2. So once if you go in this direction, this is like integration. If you go in this direction, this is like a differentiation. Okay, so now you can write the relationship between all. Okay, relationship. So what I am telling, see, impulse, the integration of impulse is unit step function. Okay, then the integration of u of t is dt. The integration of p of t is rt dt. And again you may have a doubt what is the limit. That limit is from minus infinity to t because we do not know where we are. The t could be anything. That's why I am putting t here. Similarly here also minus infinity to t. Similarly here also minus infinity to t. And but please remember that t is like positive t. Okay, like positive t because all our signals is working on the positive sides. Okay, then del t is equal to d by dt u of t. Okay, then u of t is equal to d by dt r of t, and then r of t is equal to d by dt p of t. Okay, that's a simple idea. Okay, this is the relationship between the signals. Then next, what is the properties of the signal? Okay, some basic properties. Properties of signal. Okay, if you take some signal x of t, then we are going to analyze the property with respect to t. We are not worried about amplitude. Now we are worried about the time nature. Okay, then when you have the signal, say I am having some signal. See, if this is one signal, what I can do, this is minus 1 plus 1, what I can do, sir, with this, say I can move the signal like this, or I can move the signal like this. I can do. Okay, so this is like 3, 4. This is like minus 3, minus 2. So once if I move left side, then I may get like this. Once if I move right side, I may get like this. Okay, then I can flip the signal. Say that flipping will be visible now. See, if this is minus 2, this is 3, then I can flip the signal. I can flip like this. Now minus 3 comes here, 2 comes here. I can flip the signal. Or if I am having the signal like this, minus 1, I can compress the signal. That means what? Instead of minus 1, I can put minus 1 by 2, here plus 1 by 2. I can compress the signal. Or otherwise I can expand the signal. I can expand this signal. Instead of minus 1 plus 1, I can put minus 3 plus 3. So what are all the three operations possible? I can move the signal. I can slide the signal either towards left or right. Or otherwise I can flip the signal. Simply this value gets exchanged. Or otherwise I can compress or expand the signal. Okay, I can compress or expand the signal. So whenever you have signals with respect to time, you can do all these operations. Okay, so each operation is having some name. That is, the first one is time reversal. Okay, the first one is time reversal. That means what? If t is there, then I will put minus t. That simply that will getting flipped. Okay, so it is simply flipping the signal. Then time shift. Time shift means sliding the signal. Okay, that means what I will do? I will replace t by t minus t naught or t plus t naught. Based on that, it will slide either in the right side or towards left side. This is like sliding the signal. Okay, I can slide the signal. Or the last one is time scaling. Time scaling. Okay, that means t I will replace by kt. I will replace by kt. And again k can be greater than 1 or k can be less than 1. Depending on either it is greater than or 1 or less than or 1, you will get either compression or expansion. Whether really you are getting compression or expansion, that we will see later. Okay, when you use k is equal to k greater than 1, what you are getting, you will get any one of these.